Hello everyone, and this is a special feature that we have for you for Plane Time here at Florida Aviation Network. I'm Ben Coleman, your anchor host, and we have like I said, this is special. Not everybody gets this because the first segment we had today was the air traffic controller all the way from Indianapolis Center, and this was Dean Brown. And Controller Brown kind of intimated a little bit of a story about an altimeter and how the differences of altimeters and altitudes can sometimes cause a problem when you're trying to control aircraft. So we have the weather guy, Dr. George Bartuska, is going to explain a little bit to us about how an altimeter works and how some of these situations play together or don't play together well, if you will. And he's coming to us from our studio down at Key West today. So we're going to see what George has to say about altimeters.
Okay, thanks, Ben. Those of you who watch us regularly will remember that the last time we talked about weather, we talked about radio sounds, taking soundings, sending up weather balloons, and one of the instruments in there is a barometer. In early aviation, and I'm talking balloons and dirigibles and blimps, it was very important to know what altitude they were at, and the device that was developed was the barometer was adapted to become a altimeter. We're talking about this today because of the early speaker and because the news has been saturated lately with stories about how the 5G network is going to interfere with the radar altimeters for planes on final approach. And there's been a lot of things I've read in the press that are incorrect, in that a pressure barometer, a mechanical barometer, is not the same thing as a radio or radar altimeter. So let's just talk about it in general. The mechanical barometer, and this is one from a radio sound in the 1940s, has these little cells in them. They're evacuated pressure cells. They pull a vacuum on them and they repressurize them at the standard pressure of 29.9 inches of mercury or 760 torr. And then if the pressure goes down, they expand. If the pressure goes up, they contract. A little bit bigger version of that is this inside of a precision barometer. You can see there's 3 cells. And once again, if they come apart, you can see the dial maybe move a little bit. And if the pressure goes up, which means the plane is coming down, they would come together and change the dial. So this is the pressure altimeter, standard on all aircraft and balloon flying and glider flying and all facets of aviation. And the 5G network has absolutely nothing to do with this kind of barometer. But on the aircraft, on modern aircraft that have class 1, 2, and 3 approaches and auto land, where the instrumentation on the airplane literally lands the plane itself, that involves a device to tell the aircraft how far it is from the ground, AGL, above ground level. Interestingly, during World War II, we developed what we now take for granted, something called radar. This was one of the most secret things that we and the British and other governments did during the war. And the device that creates the radar signal was top secret, more secret than the atomic bomb, because nobody knew if the atomic bomb was actually going to work. The minute the war ended, the technology to create radar found itself in all kinds of places. If you have a smartphone and you're able to look at the weather radar, you're looking at a result of that. Well, today, today, everybody has one of these devices at home in their microwave oven. It's called a cavity magnetron. This is the insides of it that I've cut out of a magnetron unit. It actually has 2 large magnets and a very large encasing around it. It's the equivalent of a vacuum tube. It has a vacuum pulled on it and has some electrodes in it. But when it operates, it basically works like a whistle, except there's no air in it. The medium are electrons going around and they create a certain frequency. Well, we can aim that at the ground in the case of the radar altimeter, and the electronics, just like in a regular radar set, can time how long it takes for the signal to go down to the ground, come back to the receiver, divided by 2, and you've got the altimeter. Well, this is a radio signal. It's RF, it's electromagnetic radiation, and the band that it operates on is very close to the band of the new 5G in the United States. We keep hearing references of they use it in Europe and there's no problem, but it's a little bit different in Europe and it hasn't been fully tested here. So once again, on the one case, we're talking a mechanical device, and by the way, the earlier barometers actually used mercury, and I said the standard pressure is 29.9 inches of mercury. The original barometers had mercury in them, and because of the danger of mercury, we don't use those anymore. But these are called siphon cells, and they expand or contract depending on the air pressure. So this gives you the altitude corrected to sea level or a known elevation on the map. The radar altimeter that uses a transmitter, something like a cavity magnetron, it's actually going to give you the exact distance from wherever that antenna is mounted on the belly of the aircraft to the runway itself, which in an auto-land configuration is incredibly important to know when the wheels are actually going to touch down on the ground. So that's a quick review of what's going on and why it's so important that that you understand the difference and why you set the altimeter setting when you go flying, because the changes in weather can change the reading of the altimeter. Okay, back to you, Ben.
And there you have it. You can always count on the weather guy to clear up any cloudy situation that we might. Is that good for a rim shot? Do I hear a rim shot there? Okay. Anyway, thanks for joining us again here at Plain Time, and it's just a pleasure to be in your company, in your presence, and come back and join us anytime that you want to find some compelling and informative information, primarily regarding aviation safety and maintenance. I'm Ben Coleman, your host. We'll see you next interview.